right, good morning. So, chapter 10 is on circles. It's kind of a monster chapter. There's just a lot of information using circles. So, we'll try to go slow and break things down, but um, let's go lines and segments. Intersect circles. So a little, I guess the letter O, but with a dot in the middle means a circle. So we've got a bunch of terminology that we need to start to look at. So let's draw a big circle here. Okay, so this line right here would be a tangent line because it intersects the circle once. It only touches the edge of the circle. Okay, so that would be what's called a tangent line. And the actual point where it intersects is called the point of tangency. So in a couple theorems, you might use that point of tangency and for sure tangent. Okay. So we have some terms that I'm sure you're familiar with, or hopefully you're familiar with. But we have the diameter, which is all the way across the circle. We have radius, which is just from the center to the edge. We have, let's go like this, what's called a chord. Okay, and then we have what's called a secant. Okay, and so the secant intersects the circle 2 times, but it's a line. So we have a tangent line that touches or intersects the circle once, or touches the circle once. A secant line that touches the circle twice. A chord, if you notice, is on the inside of the circle. It's not a line. It has an endpoint on the edge of the circle, and it has an endpoint on the edge of the circle. It doesn't keep going. Okay, so yeah, it's twice, but it's only on the inside, where the secant is twice, but it's a line that just goes through the circle. Okay, so those are terms that are going to come up not only in this section, but moving forward and later on in the chapter, I'm sure. So okay. All right. So there's some problems that'll just say, let me find it real quick. Name the circle. So whatever letters at the center, circle A, whatever letters at the middle, that's the name of the circle. Okay, so name the circle, name 2 of the radius, name 2 chords, name a diameter, name a secant, name a tangent, name the point of tangency. So you'll have a bunch of problems like that look at one picture and then you just go, okay, well there's this kind of thing. So, all right, then we're going to look at a couple theorems. Okay. So it says, well, it's the tangent line to a circle. Tangent line to a circle. It says in a plane, a line is tangent to a circle. A line is tangent to a circle if and only if, we haven't used that terminology in a while, so I'll come back to that in a second and remind you what it means. The line, so the tangent line, is perpendicular to a radius at the end point, that's weird, end point of the circle, or excuse me, on the circle. Okay, so what does that mean? So it means, if we have a radius which is from the center to the edge of the circle in any direction. So what this is saying is, like, if we have a tangent line, or if we have a line and it's perpendicular to the radius, like on the edge of the circle, then it's a tangent line. Okay, so there's going to be, but over 15 theorems this chapter. So as we go, I'm going to talk about how to organize and stuff like that, but there's going to be a ton of theorems. And it's just kind of all the stuff we know about a circle. So here's one of the things. What kind of problems might you see using this theorem? A line, so if you know it's a right angle, then you know it's a tangent line. And if it's a tangent line, then you know it's a right angle. You can kind of go back and forth. That's what that if and only if means. So regardless of how they ask the question, if it's asking you, if it tells you this line is tangent, solve something, then you know it's a right angle and you can move forward. If it's asking you, is it tangent, then you need to show that it's a right angle, and you're going to still be probably using Pythagorean theorem. If a line is tangent to the radius, it will form a right angle, which oftentimes makes right triangles. Okay, so a lot of information. We will do, the next section tomorrow and the next section the day after that, and then we'll come back and do all of them again. Okay, so just to kind of review again, so it's kind of trudge along. Okay, all right, so welcome to Circles. Have a great rest of your day, guys. We'll see you tomorrow. Couple. So if we have should do that a little bit better, but So you'll have some that it'll give you a picture and it'll say, is AB tangent? So I'd have to verify somehow that that is perpendicular right there. So it's not the greatest picture because it's hard to really draw freehand on some of this stuff, but hey, that's a right triangle. If it's true, that's a right triangle. So then a squared plus b squared must equal c squared if it's a right triangle. So I need to test it. So I have 144 plus 1225 equals, and I'm using a calculator here, 37 squared, 1369. So 144 plus 1225 is 1369. So yes, that's a right angle, therefore it's perpendicular, therefore AB is tangent. Okay, so that's one of the ways that this, theorem. Okay, so that's, you're going to have a few problems that just ask you, is this line tangent? Okay. Another way that you're going to see the problem, this one's a little bit more work, but we can do it. So on these ones, it's going to say in the directions that AB is tangent. So therefore I have a right triangle. Okay, and it's going to say find the radius. So in the book they put an R for radius, which is fine, but the radius, remember, from the center to the edge of the circle, even though that center is really far off, but from the center to the edge in any direction is a radius. So from the C to the edge of the circle right here, that's a radius. From C to the edge of the circle down here, that's a radius. So those two are the same. If it's a circle, the radius is the radius. And then they're going to say, well, this is 50 and this is 80. So it is tangent. So I know it's a right triangle. But now the Pythagorean theorem gets a little bit weird. So I have x squared from this C to B part plus 80 squared. And well, what's the length of A to C? Well, from the A to the edge of the circle is 50, and then plus, I don't know. So it's really x plus 50, or you could put 50 plus x, but I like it better with the letter in the front. Squared. So over here, 80 squared is 6,400. This, we need to distribute x squared plus 50x plus another 50x, 50 plus 2,500, and x squared, 50 and 50 in the middle, 100x plus 2,500. I will tell you that this chapter is really heavy with algebra. we'll get this circle and we'll apply a theorem, and then there's going to be this algebra stuff that we're going to have to do. Now, this one isn't like too terrible because, okay, now I need to start to solve. Okay, well, if I subtract x squared, x squared minus x squared, that goes away. X squared minus x squared, that goes away. So it becomes a much easier problem to solve because now we don't have x squareds. So hopefully you can get through to that point to where it's going to be much easier to handle. And divide by 100, and x equals 39. So you're going to have to, got a lot of work to show there, got to distribute out, FOIL out, however you remember that. But, it's going to take some doing. Okay? So you'll have a couple of those. All right. Yeah, like 2 of those. Okay. And other theorem, 10.2. I call it the ice cream cone theorem. It's called the external tangent congruence. And so it says tangent segments from a common external point are congruent. So what does that mean? It's kind of like an ice cream cone. So if it's tangent, these AB and BC are tangent, then AB is congruent to BC. Okay, just those two line or parts of a line or segments are congruent. Okay, so it's a pretty straightforward type of problem. What will you see on your work? Well, you could see something, again, it's going to be heavy algebra. Oh, okay, 3x plus 4 equals 28. And we got to solve a little equation. So it's not, those ones aren't going to be super challenging to solve. It'll be a little bit more challenging than what I just did. Oh, look at that. Let me see. So you're gonna have, let's see if I can come up with a similar problem. I'm trying to make up a problem here off the top of my head. Okay, so if it says like those two are tangent, when you make the problem equal, And then you go to solve. Okay, when you do the square root, remember that when we're solving something, like a lot of you would have just said, oh, the answer is 4. But what we're trying to find is, well, what number can I plug in for x? And the problem will be true. Can I put 4 in for x? 4 to the second power is 16. 16 times 2 is 32. 32 plus 6 is 38. Yeah, that works. But square roots really have a positive and a negative answer, because negative 4 to the second power is also 16. And then times 2 is 32, and then plus 6 is 38. So there's a couple problems at the end. You need to put both answers. And I think the book also writes it like this: positive and negative 4. Okay, so a couple problems like that at the very, very end. All right, so 2 big theorems to remember: the ice cream cone, tangents on the outside are congruent, and